This puzzle is called Disagreeable by AnalyticalNinja, another one of their 4x4 puzzles that they've been doing just about daily. Let's take a look at the rules. So, 4x4 puzzle, of course, and frenemy clues. Numbers outside the grid give the sum of the first and last digit seen in that row or column. So let's look at here. So these two digits have to add up to 5. So this was a 2, this would have to be a 3. If this was a 4, this would have to be a 1. Okay, that seems reasonable. And digit in the circle is odd, so that's just a 1 or a 3. Actually, we can just type that in. Okay, that's pretty simple rules. I'll say, like, it's nothing super complex. Let's get going. Oh, I'll put a link to the puzzle down in the description if you want to give it a try. And yeah, let's get going. So 7 is the first thing I see, which must be 3, 4. That's the only way to make that work. Now 5, this has to be a 3 or 4 to go with the 1 or a 2. Now this is going to be... If this is... One of these is going to be a low digit, one of these is going to be a high digit. If this is 2, 3... Am I missing? I think I'm missing some logic here. Definitely missing a step. If this is the high digit, if this is a high digit, this high digit goes here. Doesn't really matter. This is a 4, this is a 3, 4, 4. I guess this, if this is a high digit, this will be the high digit. Okay, that... No, that doesn't... If this is a high digit, then this is a 1. Because we'll have 2 high digits already. If this is a low digit, this is a 2, 3, then this will be a 3, then this will be a 3, this will be a 1. But if this was a 1, this could be a 1, 4, and this works fine. Oh, if this is... Yeah, if this is a high digit, this is definitely a 1. Which makes this a 2. Yeah, so 2 is in one of these two. Maybe that's the way to look at it. So if this is a high digit, this must be a 2. So this could never be a 3. Or I guess no matter what digit this is, unless it's a 2, then this is a 2. So we tried to put a 3 here. This couldn't be a 2. So this is 1... Sorry, this is 1, 2, or 4. That's a little bit. I'm still missing something, I think. So I guess what could these options? 1, 4, or 3? Just because those are the combinations that work. So this is a 3, this is a 3, and this is a 1, and this is a 2. This is a 1, this is a 4. This is a 3. Maybe. Okay, if this is a 4, then this is a 4. Because that's the only spot that it could go in this box then. And if this is a 1, then this is a 1. This is a 1, 4, 3, 1. Okay, it matches that way as well. 4. Yeah, there's definitely something I'm missing here. There's a step of logic that's I'm just not figuring out. I feel like I'm doing something silly, but I do not see what it is. These two must be 3, 4, which means this must be a 1 or a 2, which means this must be a 3 or a 4. But whatever this is does not affect what those are. Because it's just totally independent. there's some light interaction here. If this is a high digit, then there's interaction. And if this is a high digit, there's some interaction. Which I guess one of these must be a high digit. I guess this is a 1, 3, or 4 as well, since it can't be a 2. So if this is a 4, this is a 3, and if this is a 4, this is a 3, 3, 3. If this is a 1, this is a 4. This is a 1. This is a 3, 3. Yeah, I mean, that makes sense because we could have just done it this way. This would be 1, 4, that would put a 3 here. I suppose this can't be a 3 either. If this was a 3, then this would be a 2, then this would have to be a 3 for the clue. So if this is 1, 4, this is 2, this is 3. I guess these two add to 5 as well. So that makes these two add to 5? Yeah, I guess that's one way to think about it. Sorry, I had to clear my throat there. Still a little bit raspiness left from the cold. The full row adds to 10 because it's 1, 2, 3, 4 in some order. So if we know the outer two add to 5, the inner two must also add to 5. The same way, like here, the outer two add to 7, so the inner two add to 3. So this is a 1, 4, or a 3. Although that doesn't really do all that much. I guess these two digits are the same digit, which means these two digits are the same digit. That's what it is, which means these must all be 3s. That's what it is. So let's just go over that again. So these digits add to 5. These digits add to 5. Sorry, these blue adds to 5, so green must add to 5 as well. Pink adds to 5, which means green must add to 5. Now this, of course, digit is shared between the two green 5s, which means that these two digits must be the same. Whatever digit we put here, both of these are going to have to be the same digit. Now, if we just look at basic Sudoku, where can this digit go in box 1? It must go in the corner. Where can it go in box 4? It must go in the corner, which means all these digits must be the same. So what's the only option that's available in every cell? It must be a 3, which makes this a 2, which makes this a 1, 2, puts a 2 in the corner. This can't be 2, this can't be 3. This is a 4, 1, 4, 4, 1, 1, 4, 2. That was tricky. Maybe I was slow on the uptick on that. That, of course, the middle boxes, or the middle pair must be adding to 5 as well. Yeah, that was trickier than I anticipated. Still not incredibly difficult, as I always say. It's hard to make a 4x4 super difficult because there's just not that many options. But yeah, that was definitely trickier than I expected. Thank you very much for that puzzle, Analytical Ninja. I enjoyed that a lot. Time for me to get breakfast, so thank you all for watching, and go get breakfast yourself, I guess.